Hello all, let's start section 4.6, the last section for your chapter 4, correct? In this section I will cover counting. Counting for us in this chapter doesn't mean to just start count 1, 2, 3, 4, 5, counting numbers. No, it has another meaning. When you are counting probabilities, correct? Then a very simple definition for counting, you can say counting the ways something happens, right? Something happens. We call this one counting. How many ways something happens, we call that what? Counting. A quick example here to explain it well for you. For example, I'm flipping a coin, correct? And at the same time, a dice. When you flip a coin, correct? Or before even that, I will write here for you how many ways procedure can happen. Procedure can happen. If I want to calculate that, I call it counting. How many ways procedure can happen? Correct? That will be counting. Look, for coin, how many ways you can get a coin, or how many outcomes you have for a coin, correct? How many outcomes we have for a coin? Of course, 2 outcomes, correct? Which is can be head or what? Tail. For dice or die, the outcomes are 6, right? You can get 1, you can get 2, you can get 3. 1, 2, 3, 4, 5, or what? Or 6. How many ways? 6 ways. Correct? Now, if I want to calculate how many ways both of them at the same time can happen, I call that one both of them together. How many ways? If you see here, you need to find your sample space, correct? And it's so, for this one at least, it's easy to find sample space. Then you see how many ways it can happen, correct? But when it's too much, it's more than 2, then it's really difficult to find all sample space. Look here, if I try to find my sample space, sample space means all outcomes, right? If I want to find all sample space, it will be H with 1, correct? H with 2, H with 3, or head with 3, H with 4, H with 5, and H with 6. This is one of the outcomes, correct? The other one will be T with 1, tail with 1, tail with 2, tail with 3, tail with 4, tail with 5, and tail with 6. And if I count all of them, how many outcomes I have? What is my sample space? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 outcomes. The easy way, you see, if you multiply 2 with 6, it gives you what? 12. There are 12 possible outcomes. It's really easy here when you do in this example because your sample space is just 12 of them. It's not much. But In a couple examples, you will see that your sample space will be thousands. And finding those combinations are not easy. It takes days to write the sample space. Then there should be another easy way to find those, correct? Before doing another example, I want to talk about fundamental counting rule. Correct? Fundamental counting rule. I think we don't have an fundamental counting rule. Correct? If you have, what this rule says, if you have an event, that can occur m ways, and another event can occur n ways, then you can say together they can occur m times n ways. You see this example in example number 1. Coin can occur 2 ways. Dice or die can occur 6 ways. Together, this is your m, this is your n. Together, m times n, which they can occur in 12 ways. Correct? And you saw all of them in a sample space. There are 12 ways that they can occur. Correct? Now, look at to this example. For the example number 1, it's easy to use sample space. Look at this example. In this example, I'm talking about security code of ATM, for example, card. And I'll put even here a restriction. First digit cannot be 0. Even I add, cannot be 0. Usually, our ATM security code is 4-digit like this. I want to find it out here that how many ways you can make a security code for your ATM card. Even I put a restriction that the first digit, this digit, the first one, cannot be 0. What are the digits? 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. We call these digits, right? These are the digits. And the first one, I cannot use 0, correct? It means the first digit cannot be 0. I will not use for the first one a 0. If I'm not going to use 0, still I can use from 1 to 9. I can choose any number and I can put here. For example, I'll choose 4, correct? Or I can choose 1. or I can, it means I have 9 choices, actually 9 choices here to just select my first number, correct? When you come to the second digit, how many choices you have? All of them from here to here are 10 choices. And even you can choose 0 here. Then in the second one, you can use, you have 10 choices. You can use, for example, for the first one, 4. For the second one, you can use 1. Or if you say, no, 1 is not good, I'll choose 2. You can choose 2. You have 10 other combinations that you can use with 4. Correct? Now, when you go to the third digit, again, you have 10 choices. And when you go to the last digit or the fourth digit, again, you have 10 choices here. Correct? Based on the fundamental theorem of counting, if I want to find number of ways that I can make a combination here, it will be 9 times 10 times 10 times 10, which gives me 9,000 ways. There are 9,000 ways for only 4-digit code. Even I put a restriction and I said, okay, you cannot use 0 at the beginning, correct? There are 9,000 ways. Now you think how difficult will be for someone to find an ATM code, correct? It's almost impossible. With 4 digits, you have 9,000 ways, 9,000 different combinations, correct? What is the probability if you can guess at least one of them with one try? It will be 1 over 9,000. That will be your probability. Correct? Look at here in this example. I'll add more digits in it. Example number 2. First digit cannot be 0 or 1. Even I put restriction, cannot be 0 or 1. And also last digit cannot be 0. I will use here a 5-digit code. 1, 2, 3, 4, 5. In the first digit, you cannot use an 1. It means how many choices you have? 8 choices, correct? Because in total, you have 10 choices. If you remove 0 and 1, you have 8 choices here. 1, 2, 3, 4, sorry, not 1. 2, 3, 4, 5, 6, 7, 8, 9. Correct? You have 8 choices. And number 2, when you choose your second digit, you have 10 choices. Third digit, 10 choices. Fourth digit, 10 choices. And last digit, again, I put a restriction, not 0, it means 9 digit. And if you multiply all of these together, it gives you 72,000 different combinations. Look, for 5 digits, you get 72,000 different combinations. Correct? That's why people are using nowadays this locks or these security codes, because they are not easy to find those codes, right? 72,000, even with this restriction. If I remove the restriction, this number rise up. Correct? 72,000 different combination. Slowly, why I am talking about this after this example, you will see after the third example that I want to talk about a rule in mathematics. Example 3. Let's say in this example, I have 5 different fruits. The first one is an apple. The second one, I'll choose an orange. Maybe third fruit that I like is a banana, correct? Maybe grapes, the fourth one, correct? And last one, let's say what? For example, a kiwi. To bring a change between orange and kiwi, I'll put dots here. A kiwi. The question is, how many different ways I can arrange these fruits, or the easy way, if I make it easier to understand, how many different ways I can eat these fruits, correct? I can eat first apple, then orange, then banana, then grapes, then kiwi. Or I can, and I'm asking you to find 5 different ways, correct? Not 5 different ways, actually, how many ways, correct, that I can eat this. One way will be this. The other way, I can eat first orange, then I can eat apple, then I can eat maybe banana, then maybe I'll eat kiwi, then maybe grapes. Correct? How many different ways? Let's put how many types of fruits I have? 5 types of fruits. When I use, for example, for the first one, how many choices I have to eat the fruit first? I have 5 choices in the first place. I can eat any of them first. I have 5 choices. Let's say I will eat first apple. Then when you go to the second choice to eat, how many choices left? 4 choices, correct? This is 4. For example, you want to eat grapes. When you go to the third choice, how many choices you have? 3. For example, you want to eat orange. When you come here, you have only 2 choices, banana or kiwi. For example, you say, okay, I'll eat kiwi. 2 choices, kiwi is gone. And the last one, of course, you have 1 choice, which is banana. If you want to find the number of ways, how many ways you can eat these 5 fruits, multiply these with each other. It gives you 5 times 4, 20, 20 times 3 is 60, 60 times 2 is 120, 120 times 1 gives you 120. 120 different ways that you can eat this fruit, or you can say 120 different arrangements. You can arrange these 5 fruits in 120 different ways. But you see, all of these fruits, they are unique. They are not the same, correct? Different arrangements of 5, we call it unique. 5 unique items in general, not fruit, any item. Correct? There are, for 5 different unique items, you have 120 different arrangements. Correct? Now, in mathematics, we write this as a 5 and we read this factorial, not 5, right? This sign means factorial. 5 factorial. What does it mean? You start with the given number 5 and you multiply this with the numbers below 5. 5, 4, 3, 2, 1. This is the meaning of 5 factorial. 5 times 4 times 3 times 2 times 1, which gives you 100 and what? Why I put degree? 120. Correct? This sign means for us factorial. That's the meaning of factorial. 5 factorial. Correct? Or maybe if I ask you, what is 7 factorial? Correct? 7 factorial means 7 times 6 times 5 times 4 times 3 times 2 times 1. Correct? Which if you use your calculator, it gives you 5040, 5040 if you multiply all these numbers. In your calculator, you have a button that shows factorial in it. Type the number, push this button, it gives you the answer. And when I come to class, I'll show you how to find this one in your TI-84, correct? Or if I write it here, if you want to work with TI-84, TI-84, first click on Math. Correct? Then go to Probability, PRB, there is a button. And after that, choose Factorial, this sign. Type your number and factorial. Correct? You type your number, for example, 3, then Math, then PRB, then factorial. It gives you immediately 100, if it's 3 factorial, whatever the 3 factorial is. Correct? Now, sometimes we don't need to know all the combinations. We don't need to know all the combinations. For example, let's, before doing that, put a definition here for you. Important start. For any set of A, for any set of A, different items there are n factorial different arrangements. Correct? For example, if you have 10 different fruits or 10 different unique items, you can write it as a 10 factorial if you want to find how many different ways you can arrange 10 different items. It will be 10 factorial. It means 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Correct? Let me see if I can find the answer for you in my calculator. I will write type Then I'll go to math, correct? And I find from here P or B. I'll go to P or B with my arrow keys, and I'll go to factorial button, which is number 4, and enter 10 factorial, and I enter again. It gives me a number like this: 3628800, 28800. 3,628,800 different ways. If you have 10 different unique items, how many ways you can arrange them? 3,628,800 different ways. Correct? Different ways. For example, if you have 10 different shapes, a square, a triangle, a line, a circle, this is 4 of them. Now I run out of the shapes. For example, a heart, a diamond, an ace, 1, 2, 3, 4, 5, 6, 7, 3 more, maybe this one, this shape, 8, what else? Another shape. I need another shape. There are the different shapes. Let's use, for example, unique items, maybe 2 numbers. Maybe I'll use A and I'll use B. All different. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 different items. How many ways I can arrange this 10 items? 3,628,800 ways. Correct? That's the meaning of factorial. Correct. Now, sometimes we don't need to count all of these. Correct? First, I'll give you an example, then I'll give you a new definition. We will talk on a new topic. Look at this example. For example, there are, I think it's 58 if I'm not wrong, 58 counties, 58 counties in California, you need to visit, four of them. Correct? How many possible ways can you do that? Correct? There are 58 counties and you wanna only visit 4, correct? It means here for the first one 58. For the second one, when after you visit a county, how many of them left? 57 of them. After you visit another one, 56 of them, and after you visit the other one will be 55, correct? And if you multiply this three number, it gives you 10,182, 10,182,480 ways you can visit 4 counties. Correct? Or you can choose which one. It's really, for this one, it was easy, but the actual topic, you see, when you don't go to the end, you don't start like this, 58, 57, 56, 55, it means you are not looking for 58 factorial all the way to the end, to 1, correct? When we are not looking to all the way, we call this topic permutation. Permutation. What is permutation means? A different arrangements of item n unique let's say arrangements of n unique items. Correct? It means n factorial arrangement. For this, we need a formula. Correct? Your formula is n p r, like this, equals to n factorial over n minus r factorial. Now, you need some rules here, or I have to identify these letters that I used here. I will put as a rules for permutation. What are the rules? Rule number 1, you should have n different items. They cannot be the same. N different items. Correct? Number 2, what is R? The number of items to be arranged. Out of n items. For example, in our example that you are visiting 58, you have 58 counties, but you want to visit only 4 of them, your R is equal what? 4. Your N is equal 58. Correct? Rule number 3, arrangement or you can call it order matters. You have to order. Arrangement is matter here. Arrangement matters. Which county you want to go first, it matters to you. Correct? Arrangement matters. Now, in your formula, if I want to calculate for you. Here I just multiplied 3 of them and we found 10,182,480. But if you use your formula, look, my formula is NPR, permutation formula, because you have it in your calculator, and soon I'll teach you how to find this, correct, in your calculator. NPR equals n factorial over what? N minus R factorial. It means N, how much is your 8? N, 58. P, how much is your R? 4. 58P, 4, correct? Or you're looking for the permutation of 58. N factorial, it means 58 factorial over N minus R. Your N is again 58 minus R. You want to visit 4 factorial, which gives you 58 factorial over 54 factorial. Sometimes if you even don't have calculator, don't worry. Look, it's really easy to simplify this even without calculator. 58 factorial means 58 times 57 times 56 times 55 times 54 times 53 times 52 and so on, right? In the denominator, you have 54 factorial means 54 times 53 times 52 and so on. Can you see here? Because the sign in between is all multiply, multiply. Can you simplify like this the rest? You see, all of them will be gone, the rest. Only you multiply this 4 number, even if you don't have a calculator that shows NPR for you, correct? And if you multiply this, it's the same number that I already calculated for you, correct? How to use your TI, I will write down here, but if I get a chance, I'll also show you how to use it, correct? Because it's I can show it for the classes that they are hybrid, I can show it in the class, but if not, just follow this process. Write down 58 in your calculator, correct? Write down 58. Then after that, go to math, M-A-T-H. Push the math button. After that, go to PRB again, probability, correct? Use the arrow keys to go to the probability. It's on the right side of your screen, correct? PRB. After you went to PRB, find NPR in your list, which is number 2 in your list, correct? Find what? NPR, correct? After you find NPR, enter, and enter again, NPR. Something happened wrong here. Let me check. 58, math, then PRB. Math, you go to PRB and you come to NPR, then enter. When you enter NPR, they are asking you in this calculator, it asks you what is your R, correct? If you plug in 4 for R and enter, it gives you the number, correct? Because we choose our R4, correct? If you plug 4, it gives you the number which is 10,182,480. This is how you use your TI-84. For example, let's say I have 34 and I wanna just go, my N is 34 and my R is 6, correct? What I'll do in my TI-84, I'll type 34, then I'll go to math, correct? Then from there to PRB, probabilities. From this list, I'll choose NPR. And when you select NPR, it asks you for R. How much is R? Then type 6, then enter. It gives you the number. Correct? This is how you deal with TI-84. Other than that, if your N is 34 and your R is 6 and you don't have a calculator, your formula is NPR equals N factorial over N minus R factorial. Correct? It means 34 P6 equals 34 factorial over 34 minus 6 factorial, which gives you 34 factorial over, what is 34 minus 6? Gives you 28 factorial. 34 factorial means 34 times 33 times 32 times 31 times 30 times 29 times 28 and so on, right? 28 factorials means 28 times 27 times 26 and so on to the 1. But you see, you can start canceling from here. The rest will be cancelled. You only multiply from 34 to what? To 29. If you don't have a calculator, you have to multiply all these numbers. Correct? But I know most of you, you have the calculator. Here, what I talk about, it was different arrangements, correct? Different items. Let's do another example for you here. There are 10 people. There are 10 people who wants to be president. Wants to be president. Correct? President, let's say vice president, maybe secretary of treasury, and let's say defense, or I call it here general. One of them wants to be a general. Correct? We want to select 4 people to lead the country. Correct? One president, of course. Second vice president, the second person. The third one maybe secretary of treasury. It's important position. And number 4, of course, the defense, or I call it here for you the easy way, general. correct? How many ways we can arrange out of 10 people, correct? I'm looking for 10p4, correct? Which means 10 factorial over 10 minus 4 factorial, which gives me 10 factorial over 6 factorial. What is the meaning? Even I'm not using here calculator. What does 10 factorial means? 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, correct? Over 6 factorial, which is 6 times 5 times 4 times 3 times 2 times 1. One more thing that I forgot to put for you. 0 factorial is always 1. Keep in mind. We count 0 factorial always as a what? As a 1. Now, you see here, you can cancel 6 with 6, 5 with 5, 4 with 4, 3 with 3, 2 with 2, and 1 with 1. You only multiply 10 times 9 times 8 times 7, and if you multiply these numbers, it gives you 5040, 5040 ways. Correct? Last part of the lecture, look at this example. I don't have any more unique items. For example, I have 3 apples and I have 2 oranges and I have 5 bananas. 1, 2, 3, really bad bananas, 4, 5. 5 bananas, correct? How many ways I can arrange, correct? 3 apple means 3 factorial, agree? 2 oranges means 2 factorial, and 5 bananas means 5 factorial. Here they are not unique. You see, you have 3 apples, 2 oranges, and 5 bananas. Now make a note. For non-distinct or non-unique, non-distinct items, correct? We use this formula. N factorial over N1 factorial times N2 factorial times N3 factorial, and so on. Here, N is total items, N1, N2, N3, and so on. Or the counts of non-distinct items, of non-distinct items. Correct? Now, an example for this. A very interesting example. Let's do this one. The word statistics. Statistics. I will ask you, how many different ways how many different ways could you arrange these letters? How many different ways you can arrange these letters? Correct? All of them. In the word statistics, I have 10 letters. Correct? How many S I have? How many S I have? 1, 2, 3. It means S is 3 factorial. How many T I have? 1, 2, 3. Your T is also 3 factorial. How many I have? 2 factorial. Correct? 2 of them. And how many A? A is of course 1 factorial. And C is 1 factorial. Correct? You see, they are non-distinct. They are not unique because you have 3 S's. You have 3 T's, 2 I's, correct? Then which formula I'm using? N factorial over N1 factorial, which is this formula. N1 factorial times N2 factorial times N3 factorial, and all of them. Your N is 10 factorial over, multiply all of these, 3 factorial times another 3 factorial times 2 factorial times 1 factorial and times another 1 factorial. Correct? 10 factorial means 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 3 factorial means 3 times 2 times 1. Another 3 factorial means 3 times 2 times 1. Correct? 2 factorial means 2 times 1. And 1 factorial means 1. 1 factorial means 1. The ones that you can cancel, cancel. You can cancel 3, 2, 1, 3, 2, 1. Correct? And also you can see, you can simplify this 3 with 6. You can simplify this 2 with 4. This 2 with another 4. I can remove these 2 and I can remove 4. Correct? I can remove 3 from the denominator, or I can simplify 3 with 6, which goes 2 times like this. Correct? At the end, I will multiply 10 times 9 times 8 times 7 times 5 and times 2. This 2. Correct? And it gives me the total combination of what? 2520. No, actually not 2520. $50,400, I think. 50,400 different ways. Correct? Multiply this. I'm not using calculator. Multiply, how much is that? Correct? Last part. Sometimes order means arrangement doesn't matter. Correct? For example, you are going to Disneyland and you wanna go to 5 different rides. Correct? Go on 5 rides. Out of let's say 25 rides that it's in the park. For example, here you don't care which ride you want to go first, correct? Order doesn't matter, correct? This example, how many ways you can select 5 rides, we call this combination. When order matters, we call it permutation. When order doesn't matter, we call it what? Combination. Again, rules for combinations, you have to know the rules. Rule number 1, n distinct items. For example, 5 different rides is n, or 25 different rides is all of them is different, correct? They are not unique. Number 2, rule number 2, select R. R is which one, how many of them you should go. For example, here 5 rides, correct? Select R items. Number 3, arrangement. Or you can call it order, doesn't matter. You don't care which ride you want to go, but you want to go 5 of them out of 25, correct? We call this one combination, and the formula is NCR, and it's equal to n factorial over n minus r factorial times another r factorial. With TI-84, it's the same process, but it's number 3. You can see there NCR when you go to probability, correct? For example, for this, my n is 25, right? How many combination? I want to go 5 of them. My n is 25 factorial over 25 minus 5 factorial times 5 factorial, because r is 5, correct? Which gives me 25 factorial over 25 minus 5 gives you 20 factorial times another 5 factorial. You can simplify this later and you see how much is that, correct? This was all about your 4.6. I'll stop the lecture here and see you all in chapter 5.